This is Mrs. Thompson, and we are now looking at Lesson 1-7. In Lesson 1-7, what we want to be talking about is we're first going to look at what's called our terms. Terms, like terms, and constants. So when we think about what is a term is usually separated by addition signs. You get to watch me misspell this. Separated by addition signs. So when we think about our terms, we're going to always change our subtraction to adding, so we make sure we keep the correct sign. So here we would change this to plus, and we would actually have 1, 2, 3, 4 terms. You notice down below here it says like terms. 3xy and 2xy are like terms because they have the same variable factor of xy. Notice that the x and y that they both have are both to the first power. So when you're looking at your definitions for like terms, the 19 is the constant. The constant is simply the number. Simply the number as we are looking at that. So when we talk about terms, we also talk about coefficients of our terms and constants. So as we look at this phrase, one of the things we always want to do to separate our terms is change subtraction to adding the opposite. So plus a -5, plus a -12. -12 is the constant. We have 4 terms in our problem, in our expression that we are looking at. Remember, this is an algebraic expression. It is not an equation. The coefficient is the number in front of your variable, or times, the number times your variable. So when we talk about coefficient, it is the number, can be a fraction, can be a decimal, can be an integer, the number times your variable. Now you can see my writing with the pad is maybe improving, and hopefully you can hear this a little better than the last video. Like terms and unlike terms. Here's some different terms: 7a negative 3a, 4x squared and 12x squared, 6ab and negative 2a, xy squared and x squared y. When we talk about a variable factor, that's what do they both have in common? They both have the a. Are they like terms? Yes, they both have a to the first power. We'll soon see adding like terms, and I know you did some of that last year. Both have x squared as our common factor. They are like terms. Here, when we look at these, this has the variable factor of a, b, and a. Are they the same? No, not like terms. Xy squared and x squared y. They do not have the same exponents. So in order for them to be like terms, we would have to have them both being x squared y, and not, notice here, x is to the first power, y is to the second. Here, y is to the first power. Now, when we are looking at these like terms can be added together, unlike terms cannot be added together. So, just being careful of that. If we are looking at combining like terms, you might see this expression, b plus 4c in a parenthesis. And the parenthesis is used mostly here to separate our terms. 6b plus 2c plus 3d. We're going to group the like ones together. And nice for you, I colored them even the same. b plus 6b. Remember, what is our coefficient of b? Our coefficient of b that we might want to be taking a look at is actually 1. So if it helps you to write in a 1 in front of that, 1b plus 6b. That's how we got 7. We're adding the coefficient, keeping the variable the same. 4c and 2c we group together. 4 plus 2 gives us 6. The c stays to the first power, and then 3d has no like terms. Sometimes it's easier to think of algebra tiles. We will have a set of algebra tiles if you ever want to think of looking at them that way. 3x squared. The big square is x squared, so we have 3 of those. The negative 5x gives us 5 of these pink longer ones, plus 7. If we are adding that with x squared, that is, remember, a 1x squared, positive 2x, so we have 2 yellow rectangles, minus 1. We could have a plus a -1 also. We're going to regroup them. We put our x squareds together. 3x squared plus 1x squared gives us 4x squared. Here, if we're adding -5 and 2x, remember, Since we are actually negative 5 plus 2, we're going to subtract, and we actually end up with a negative 3x. Could you put plus a negative 3x? Yes. More simplified answer is what I have first, the negative 3x. And in the last one, we are looking at 7 minus 1. So how many positives do we have left? We have a plus 6. This would be our simplified solution. I would like you to look at these problems. I am going to put this in a PDF for you. So if you want to print out just this page, or if you want to do these notes on a separate sheet of paper, I would take those tomorrow also. So we're going to try a few. Pause it if you need to. We're going to regroup them. When we regroup, again, this might be done with algebra tiles in class, we're going to put our x squareds together. 4x squared plus a negative 3x squared. Next, I'm going to put my x terms. So I have plus, and again, I'm going to group them. 1x plus negative 5x. Someone said, what if I put minus 5x? I like to, again, rewrite my subtraction as adding the opposite. And then our constant terms. And our constants are negative 4 plus negative 3. If we're adding these together, 4 plus negative 3 signs are opposite, 1x squared. In simplest form, do I have to have the 1? No, I could just write x squared. 1x plus negative 5x. Remember, this is not going to become an x squared. We are adding the coefficients in front. So we are going to have a plus negative 4x. Could I have just minus 4x? I could. Negative 4 plus negative 3, we're going to add those together, keep the sign the same, negative 7. So I can have plus a negative 7 or minus 7. Both, as we look at these, should be in simplest form. If you have not tried number 5 and 6, try those. Pause the video, and I'm going to do it with you. So pause it and try it, and then watch what we do. Again, we're going to group 2x squared plus the negative 1x squared. Boy, some of my writing is tough on these. Sorry about that. We are then going to group the x terms. We have a positive 10x, oh, I thought I changed color on you, and a negative 4x. Add our constants. As we add the constants, we are going to have negative 1 plus 4. In simplest form, we are going to have x squared or 1x squared. X squared or 1x squared plus 6x plus 6x plus 4 plus negative 1 gives us 3 as our simplified answer. We'll check this last one. You got to be really tricky here. There's a negative in front. What happens with a negative in front? So what we are going to do, and this is a little bit of the distributive property, and maybe we'll leave this one and talk about it in class and what the distributive property does. Here we're going to do with looking at our like terms. So what we notice is we have mn to the fourth, m and n to the fourth. Are they like terms? They are. We're happy. We are going to add the coefficients. So sometimes we like to put it this way. Negative 7 plus a negative 5. Again, remember, subtraction can always be changed to adding the opposite. M and n to the fourth. You can think of it that way. Negative 7 plus negative 5 gives us a negative 12. M and n to the fourth. Notice that in our original problem and in our final answer that these exponents, m to the first, n to the fourth, are always the same. They are not changing. We don't change them or increase them to m to the second and n to the eighth unless we are multiplying terms, and here we are simply adding. Do we have like terms as we look at problem C? So if you're writing down problem C in your notes, we would look at y to the third z. Oh, not y to the third z, yz to the third. So our two like terms I'm going to underline. The coefficient of this last one is 1. So if we are adding them, we have 7 plus the 1, and they both have y to the third and z, the common factor, minus 6y and z to the third. 7 plus 1 gives us 8. The simplified answer is 8. Y to the third z minus 6 y and z to the third. Here's a few more for you to practice. What I would like for you to do is to have these in your notes so that tomorrow in class we can look at the solution. Try them, see how you do, and if you have questions, we're going to look at those before we start our homework. Hopefully this was a little better. You could hear it a little better, and the video went